and I'm from section DE2B, and now I'm going to present my video on general skills. Thank you. So guys, first of all I'm going to explain to you guys about introduction for BJT and its significance in electronics. A BJT, which is bipolar junction transistor, is a semiconductor device with three terminals, which is emitter, base and collector, which used to control the flow of current. It operates by using a small current at the base terminal to control a larger current between the collector and emitter. There are two main types of BJT, which is NPN and PNP. The BJT is significant in electronics because it acts as a switch or amplifier, making it essential in many electronic devices. It widely used in amplifiers, digital logic circuits, and automatic control systems due to its ability to handle signals and control power efficiently. Next, I'm going to explain to you guys about objective of practical work 3, which we do about the BJT transistor. So first of all, the objective of this practical work is to sketch the symbol of transistor. Second is the second objective is to using the multimeter, which is ohm range, to check and identify the transistor electrode, which is terminals. Second one is the NPN or PNP type of bipolar transistor, and the third one is silicon or germanium type of bipolar transistor. The third objective is to identify the terminals of bipolar transistor from its physical shape. So guys, next I'm going to explain to you guys about the three BJT terminals and its function. A BJT has three terminals, which first one is emitter, which we label as E, and function of this terminal is to emit charge carriers, which is electrons or holes, into the base. And the second terminal is base, which we write as a B, and its function is to control the number of carries going from emitter to collector. It is thin and lightly doped. The third terminal is the collector terminal, which we label as C, and its function is to collect carries from the emitter through the base. It is where the main current flow out. For the next part, I'm going to talk about how current flow through the terminal in NPN and PNP. First, we are going to see the NPN transistor. For biasing, the base emitter junction is forward bias and collector base junction is reverse bias. The current flow, a small base current, which is IB, flows into the base. This allows a large collector current, which is IC, to flow from collector to emitter. Emitter current, IE, flow out of the emitter. The direction of the current is IB is base, IC is collector to emitter, and IE is emitter, which is outward. For PNP transistor, the base emitter junction is forward bias and the collector base junction is reverse bias. For current flow of PNP transistor, a small base current IB flow out of the base. This allows a large collector current IC to flow from emitter to collector. The emitter current IE flows into the emitter. The direction of the current is IB, base is outward, and the IC is from emitter to collector, and IE is emitter, which is inward. So guys, before start testing the transistor terminal, we need to reverse the multimeter probe. So we need to plug the red probe at the negative COM output of multimeter and the black probe to the positive output of the multimeter. So guys, for the next step, we are going to select a ohm range selector to times 10 ohm or times 100 ohm of multimeter. So now I'm going to choose times 100 ohm scale at the multimeter. So after that we need to calibrate our multimeter, so until the pointer shows 0 at the ohm scale. And then next we are going to name the three terminals of each transistor. So as you guys can see, now I'm having a BGT transistor which is 2N2222, and for this I'm going to name the first terminal as terminal 1, second terminal as terminal 2, and the third terminal as a terminal 3, and then I'm going to place it on the breadboard. So guys, for the first testing variation, I'm going to touch the red probe of the multimeter to the first terminal, and touch the black probe to the uh, second terminal. So now we get our reading in the multimeter, which is infinity. For the second variation, we need to, without changing the red probe, we need to move the black probe from the second terminal to the third terminal, and now it's still infinity ohm. And the next one, now we need to change the first terminal to the black probe, and touch the red probe to the second terminal of the transistor. Now we get a reading in our multimeter. So now without changing the position at the first terminal, and then we need to move the other probe to the second, from the second terminal to the third terminal. Now we got our fourth reading, which is infinity ohm. So that's it for finding the base terminal of the transistor. Now we need to analyze the record that we get. So guys, for the next one, we are going to see how to identify the collector or emitter terminals in our transistor. So for that, first of all, we need to change our ohm range to a higher range, example times 100k, or a higher ohmmeter scale. So I'm going to choose times 10k, and now we need to do the calibration at the multimeter until the pointer reaches 0 at the ohm scale. So now we need to observe the color of the probe that touches the base terminal. So as you guys know, the color of the probe that touches the base terminal is red. So notice that there is a slight difference between the two readings. So now to find the base terminal, to find the collector or emitter terminal, we need to reverse the color of the probe that touches the base terminal. So I'm going to reverse the red probe to the black probe. And then we need to put another probe to the wherever terminal 1 or terminal 3. Now I'm going to put it on terminal 3. So as you guys can see, the reading is infinite. So now I'm going to put another probe to the first terminal. So as you guys can see, the reading multimeter showing a reading. So it means, according to the theory, the terminal that gives the lower resistance is emitter, and the terminal with the higher resistance is collector. So now we can confirm that the terminal 3 is a collector and the terminal 1 is a emitter. Now we are going to discuss about NPN and PNP BGT. A BGT transistor has two types, which is NPN and PNP. An NPN transistor allows current to flow from collector to emitter when a small current enters the base. A PNP transistor allows the current to flow from emitter to collector when a small current leaves the base. In both types, the base controls the transistor operation, but the current direction and voltage polarity are opposite. NPN is more common due to better electron mobility. So guys, now we are going to see the difference of NPN and PNP in terms of current flow, direction and biasing connection. First of all, we are going to see about NPN transistor. For current flow, for the NPN transistor, the current flow from collector to emitter. The base current flows into the base. For the biasing, the base emitter is forward bias, collector base is reverse bias, and the base voltage is positive WRT emitter. For next one, we are going to see the difference of PNP transistor to NPN transistor. For the current flow, the current flows from emitter to collector, and the base current flow out of the base. And for the biasing of a base emitter, it's forward bias. For collector and base, it's reverse bias, and base voltage is negative WRT emitter. So guys, now we have two schematic symbol of transistor, which is one is NPN and another one is PNP, and now we are going to see how to identify the NPN and PNP using circuit symbol. So for the NPN transistor, the arrow is going to the emitter. So as you guys can see, the arrow is going to the emitter terminal. It means it's an NPN transistor. And for the PNP transistor, the arrow is going onward to the base terminal. So as you guys can see, it's going onward to the base terminal. It means it's a PNP type transistor. And for identifying the NPN and PNP transistor using multimeter, I made a short video by doing practical 3. So guys, now we are going to see how to identify the type of transistor, whether it's NPN or PNP. So from just now, we know that our base terminal is the second terminal of our transistor. So according to the theory, if the terminal that touches the base terminal is positive, it's the NPN type transistor. If the probe that touches the base is negative, it's a PNP transistor. So as you guys know from the data that we get from the experiment just now, we know that the probe that touches our base is positive. So it means our transistor type is NPN. So guys, now we are going to talk about the material that used to make BJT. So a BJT is made using semiconductor materials, primarily silicon or germanium. Silicon is the most commonly used due to its abundance, thermal stability and good electrical properties. A BJT has three regions, which is emitter, base and collector, which are made by doping silicon with impurities to form N-type with extra electrons and P-type with holes materials. In an NPN transistor, the emitter and collector are N-type and the base is P-type. For PNP, it's opposite. These materials form two PN junctions, allowing the transistor to control current flow. Furthermore, now we are going to discuss why silicon is used more in modern BGCs due to its thermal stability and electrical properties. Silicon is more commonly used in modern BGCs because it has a better thermal stability and good electrical properties compared to the other semiconductor like germanium. Silicon can operate at higher temperature without breaking down, making it more reliable in various environments. It also has a high energy band gap, which is 1.1 eV, which means it has lower leakage current and better performance at higher voltages. Additionally, Silicon is abundant, more cost effective, and forms a strong stable oxide layer, which is SiO2, which is useful in manufacturing and protecting the transistor. These advantages make it silicon ideal for modern electronic devices. So guys, now we are going to find out whether our transistor type is silicon type or germanium type. For that, we need to touch the red probe to our emitter terminal. As you guys know that the first terminal is emitter, and the black probe to the collector terminal, which is the third terminal. Now we get our reading in a multimeter, and for the second one we need to touch our we need to reverse the probe. So we need to touch the black probe at the first terminal and the red probe to the third terminal. So as you guys can know, we get two infinite reading. So it means if we get the both readings show is high, the reading then the transistor type is a silicon type transistor. So it means our transistor is a silicon type transistor. So that's it. So guys, for the conclusion, we are going to discuss about importance of understanding BJT's terminals, types and materials in electronic circuit design. So understanding BJT terminals, types and materials is important in electronic circuit design because it helps you use the transistor correctly and efficiently. Knowing the three terminals, emitter, base and collector, lets you connect the transistor properly in the circuit. Understanding the types, which is NPN and PNP, help you to choose the right transistor based on the direction of the current flow and the biasing needed. Knowing the materials like silicon helps you to understand the transistor performance, thermal limits and reliability. Overall, this knowledge ensures the circuit works as intended, avoids damage and improves the efficiency. So now I'm going to summarize the practical 3 that we did just now. So for practical 3, we learned three things, which is we learned to how to identify the type of transistor, whether it's NPN or PNP, and we learned how to identify the base three terminals of the transistor, and we also learned how to identify the whether the transistor is silicon or germanium.